My name is Marcus William. Today I'll be talking to you about my project, the Wastefish. I named my project the Wastefish because it is a reiteration or smaller version of a different robot that uses a similar mechanism called the Waste Shark. I chose this project because I started to see a lot of garbage and floating and just generally floating debris in smaller bodies of water around the Mississauga and Hamilton areas. And I thought that the best solution to this problem would be a robotic one. The purpose of my project was to create an inexpensive yet easily transportable device for cleaning floating debris out of smaller bodies of water. So the first step of my procedure is to design the robot in CAD. I use Tinkercad because it is the easiest form of Tinkercad. It is the easiest form of CAD to learn. And then I also 3D printed some of the floats and laser cut the side panels out of acrylic. The next step was to code based on the design, using PictoBlocks, which is a block code app that can transfer your block code into regular C++. And then the last step was to assemble. So I fused the 3D printed pieces, and then I put the Arduino breadboard motors and other electronics into the housing. Then I connected all the pieces, like the motors, to the Arduino and the motor driver. The last step was to test the robot in some sort of water, which I used just a regular tub to test its buoyancy. Also to test its functions such as forward, backward, left, and right to make sure that everything is connected properly. Even though I was not able to test my robot in the real world, because of the climate right now in the GTA, I was able to test two things, which are if it was buoyant, which it was, and how much load or waste it can carry in its basket. I was able to compare this to some other robots, such as the Waste Shark and the Clearbot, which is similar in function to the Waste Shark and my Wastefish, but uses a different mechanism. On this graph, I calculate the overall score for each robot by dividing the price by the amount that it can hold. The lower score means the better price to load ratio. My robot can be used in several situations. One of them is that the government can try and find manufacturers to make smaller robots like these that can clean smaller bodies of water. Or they can find a company to do a program that does those things. Also, businesses with small bodies of water, such as ponds, on their facilities can use a robot like this to keep them clean instead of hiring multiple people. My first trouble that I had while trying to create my robot was that my 3D printer broke. This ended up not being too bad because I was led to a maker space in the Burlington Public Library, and the people there showed me that if I were to laser cut out of acrylic or any plastic, it would be more efficient and it would take way shorter time than trying to 3D print all the parts. So what I did is that I 3D printed the net and the floats out of PLA or Polyterra, and I laser cut the side panels out of acrylic. The next thing was trying to make the motor spin. They weren't wired correct. The H-bridge I was using broke, and they also weren't wired because they weren't wired up correctly. And the solution to that was using a motor driver that I could find at a local electronics store. To continue my project, I'd like to make it bigger to where it's still portable, and also add solar panels. I was not able to add solar panels because I didn't have enough space in the housing of my robot to put the electronics needed to control the solar panels. In my project, I used the scientific method First, I asked the question, can there be a portable and cheaper version of some of these water cleaning robots, such as the Waste Shark and Rowboat and Clearbot? Next, I did some research. I researched a couple of the most common popular robots to see what was common between them and what was modifiable to make a smaller form factor. Next, I hypothesized. I said that this will be possible if the net does not create drag, but is still fine enough that stuff like bottle caps and just smaller pieces of plastic that still aren't microplastics will not be able to fall from the net. Then I experimented. I tested the different parts in AutoCAD in real life. Then after making the robot, I tested each function such as forward, backward, left, and right. And lastly, I collected data and then I examined and concluded. I tested the net in the amount of trash it can hold compared to some of the other robots that I based my robot off of. And I saw that the price to load ratio was not as good as the other robots. This is just because when trying to make something smaller and smaller form factor, I used similar grades of technology, which did not make it as cheap. Did not make it as cheap. Also, a lot of these robots are made on an industrial scale, which means that parts for them would be a lot cheaper than they are if I were to buy them. I hope you found my project interesting, and thank you for listening.